Okay, in this video, what I'm going to do is show you how to do a Pearsons rank correlation in SPSS. So I've opened up just a very simple data set here in SPSS. So we've got variables here of gender, male or female, we've got age, we've got height, we've got weight, and we've got body mass index. And what I'm going to do here is look at the correlation between height and weight. So fairly straightforward. What we're hypothesizing is that as people get taller, they will also get heavier. And we would expect that to be a linear relationship. So to perform this correlation, we first have to decide which type of correlation we can perform. And remember, there's two types, so we can either do a Pearsons correlation or we can do a Spearman's correlation. And a Pearsons correlation is the parametric test, and the Spearman's correlation is the non-parametric test for correlations. Now, just like for looking for differences, if we want to be able to perform a parametric test, then we have to satisfy the same criteria when we want to look at a correlation. So first of all, our data have got to be of interval or ratio scaled. So height and weight are, they will be ratio scaled, interval or ratio scaled. And they have to be normally distributed. And so I've checked the distribution of these data and they are both normally distributed. So we can use a Pearsons correlation to look at the relationship between height and weight. Okay, so to do the correlation, to do the test, we go to Analyze, as we do for all tests. And this time we're going to come to Correlate, and then we're going to go to Bivariate. Select OK. Now this is a really straightforward test to perform. You can do the Pearsons and the Spearmans at the same time if you wanted to. But what we're going to do is just select the variables that we want to do the Pearsons correlation for. So put our variables in this box, and so we're going to bring across height, and we'll bring across weight. And make sure Pearsons is selected, make sure two-tailed is selected, and then that's you ready to go. You can perform the test. Hit OK. And so you're going to get a box that looks something like this. And you can see here that we've got three different numbers in this box. And then we've got basically a matrix here where it's showing us the correlation between height and height, height and weight, weight and height, and weight and weight. So obviously we're not interested in the correlation between height and height, that's useless. But we are interested in the correlation between height and weight. And what you can see here is we've got a Pearsons correlation coefficient. We've got our p-value, our significance value, two-tailed. And we've got the number of values that were included in our analysis. So let's look at this Pearsons correlation coefficient first. So we've got a 0.577. And if you remember from the lecture, Pearsons correlation coefficient can be anywhere between -1, which would be a perfect negative relationship, to 0, no relationship at all, and up to +1. And +1 would be a perfect positive relationship. So here we've got probably what you would call a moderate correlation between height and weight. It's not perfect by any means, but it's certainly a moderate to strong correlation there between those two variables. Okay. And we want to know whether it's significant or not. So is this a significant correlation, or would we likely just find this strength of correlation by chance? And you can see here that the p-value is 0.000. That just means that it's lower than 0.05, and it tells you here actually the correlation is significant at the 0.01 level. So this has more decimal places, you just can't see them because it's only presenting it to 3 decimal places. So we would say that this is a significant correlation and it's a moderate to strong correlation, positive correlation between height and weight. And then the n is just the number of participants that have been included in that. Okay, so then you can use that data in your results section to support your written results and to support your scatter plot that you'll produce of the relationship between your two variables. And that's us.